So I'm recording the class. We can begin. Today we are going to continue looking at linear regression. And before we go to the practical side of it, so we need to understand how regression works and how we can differentiate between regression and classification. So when dealing with supervised learning tasks, we have regression and we have classification tasks. And what we are looking at the moment is regression. So for logistic regression, this is whereby we have multiple features that to we want to use to predict a continuous variable. Okay. So what do we mean by a continuous variable? So just give me a minute. I have to zoom in. I forgot that. Yeah, so I think that's better. Okay. So when dealing with logistic regression, we have multiple features that we want to use to predict a continuous variable. So what is a continuous variable? So a continuous variable is a variable that can take any value between a given range. So an example will be values such as 12, 12.5, 40, 23, 11, 34, 35.6, and so on. So that's an example of a continuous variable. So what we usually do is for us to predict these continuous variables. So how do we predict them? So what we usually do is we use the equation y should be equals to mx. So it should be something like m1 x1 plus m2 x2 plus up to mn xn, where n is the last feature you have in your data plus b, which is a constant. So this is the equation that we usually use. So that's what we have for logistic. It's not supposed to be logistic regression, but it's supposed to be linear regression. So apologies for that. So what you can do is you can go ahead and create a new IP YNB file and name it linear regression. So for this file, we are going to demonstrate how this equation works. And the data that we are going to use is the data that we had in the previous class, and that should be the TIPS dataset. And we are going to implement things that we've been learning from day one, and that is data encoding. So for example, here we have sex column, which is categorical. We have numeric columns, which we don't have to deal with. Okay, so create your IPYNB file and then we can begin. So I'll give you 2 minutes to work on that and then we can proceed. Okay, so as you are working on that, I can also copy the code from the other class notebook for some of the libraries we need in this section. So these are the libraries we'll need. So we will need the pandas library, numpy, matplotlib, and then we will also need to work with Seaborn. So that's what we have. So 2 more minutes, you work on this and then we can proceed. So at 8:13, we continue. Okay, so I guess you are ready and we can proceed. So the first thing we need to do is import a sample data that we can work with. So what I'm going to do is I'm going to import the tips dataset from Seaborn. So we're going to have tips being equal to sns.load underscore dataset. Then we are going to have our tips dataset. Then tips.head will show us the columns we have in this data. So we have the total bill column, we have the tip column, we have the sex column, we have the smoker column, day column, time, and the size column. So before we proceed, so as you are copying this code, so what we usually need to do is we need to define our problem statement. Okay, so we usually have to define our problem statement. And for the problem statement, you need to try and ask yourself, so what are you trying to achieve? Okay. So once you've answered that question, so you need to also ask yourself, how am I going to solve it? Okay. And then how am I going to measure it? So those are the four things you need to look at. So the first thing is why. So first thing should be what are you trying to achieve? So in this case, what are we trying to achieve? So for me, I would try and say I'm trying to predict the amount of tip a customer should is expected to leave based on all these features that we have here. So that's my problem statement. So I am trying to predict the amount of tip a client will leave. So you can ignore this theory part and just focus on the code part, as I will share this IPYNB file with you and you can copy the code part. You can copy the theory part, sorry. So I'm trying to predict the amount the tip amount a client will leave. So based on all the client's features. Okay, so that's what I'm trying to achieve. So how will I solve it? So I will create multiple I will create a multiple regression model to solve the problem. Okay, so this should be a linear regression model. So linear regression is one of the models you can use in this case. And how am I going to measure its performance? So I'm going to calculate the R squared score. So you know what the R squared score is. So already I've defined my problem statement. So what am I trying to achieve? Then here I've mentioned that I'm trying to predict the amount of tip a client will leave based on all the features. So what I'll do today is I'll ignore all the EDA parts and we will go directly to the model creation part because already I know you guys are good at EDA. So the first thing we need to do is we need to encode these categorical columns over here. So what I'll do is I'll use the map function. So for example, I can type in sex dot unique. So I can have tips. Then I select the sex column, then I get the unique values. So these are my unique values. I'll copy them and then paste them here in a new column. Then I'm going to create a dictionary here. And I'm going to say let females be 1 and males be 2. So this will be my sex underscore map. Then the next thing we need to check is the smoker column. Or there is an easy way of us encoding these columns. So let's actually use that. So using sklearn, so encode categorical variables to numerical using ordinal encoding. So what we will do is we will have from sklearn.preprocessing. So we import this library from sklearn. We import ordinal encoder. Then what we do is we instantiate the encoder. So instead of us using the dictionaries and all those maps, we just use this single library to help us encode our data. So we will have our encoder being equal to ordinal encoder. Then after importing our ordinal encoder, we feed and transform the data. So we will have encoder dot feed transform. Then we will have our tips dataset. Okay. So that's it. So just a minute. So what I'll do here is I'll create a copy of the tips dataset. So we'll have tips underscore copy being equal to tips dot copy. And then here I can use the tips copy just in case I've missed any steps. So yeah, there we have our data. So for columns that were not categorical, they should be categorical now. So after encoding, what I'll do is I'll create a data frame with the encoded data. So this data frame will, so here you can see fit transform creates an array. And this is a three-dimensional array which has all the columns in here being numeric. So we have to transform them back to a data frame if we want to clearly know what each part of the array here represents. Okay, so what we will have is we will have tips copy being equal to pd dot data frame. Then we will have encoder dot fit transform. Then we transform tips. Then column names should be equal to tips copy dot columns. So I can go ahead and delete this part. And then we can run tips underscore copy dot head. And now we have our data, which is now all numeric. Yeah, so I'll give you 5 minutes to copy this code and then we can proceed. So if you have any questions concerning this encoding method, you can ask, but I guess this is one of the easiest encoding methods you can use, which doesn't create any new additional columns. So one hot encoding creates additional columns, but ordinal encoder does not add any new columns. So it just replaces your values with zeros and ones. And if you have more than two values, you'll have 0, 1, 2, 3, and so on, depending on the number of categorical variables you have in your data. So 5 minutes at 8:27, we proceed. So copy these two code parts and then we can proceed in the next 5 minutes. Okay, so a few more seconds, you complete working on the code and then we can proceed. Okay, so we can proceed. So the next thing we need to do is we need to create the features and the target variable. So we will always be using this same method of creating our features and our target variables. So we will have our x, which will be the features, being equals to tips underscore copy. Then we drop the target column. So the target column here should be tip. So tip is our target column and axis should be equal to 1. So when we say axis is equal to 1, we mean that we are dropping the column itself. Okay. Then for our y should be equals to tips copy, and then we select the tips column itself. And here we will have created our feature and target variable. So it's as easy as that. So there are additional steps we can follow, but I'll show you that in the next class. So things like creating your training and test set, but we will discuss that in the next session. So 2 minutes you work on this and then we can proceed and fit our model. Yes, yes, Jesse.
So I'm getting an error,
So
and
for this part here,
no,
this upper part.
yeah,
Okay.
the
So what's the error message saying?
name encoder is not defined.
So check your spelling here. So check everything is okay. You can also share these in the chat section and then you can check, compare with what you have. In the meantime, the others can continue copying this part here. So I guess we can proceed and we will go to the last part, which is fitting a linear regression model. So first of all, we have to import linear regression. So we'll have from sklearn.linear model, import linear regression. Then what we do next is we instantiate the model. So we'll have LR So LR is short form for linear regression, being equal to linear regression. After importing linear regression, what we do again is we fit the model. So we'll have lr.fit x, comma y. And then lastly, what we do is we make predictions. So our y pred will be equal to lr.predict x. So here we are not really using the predictions that much. So when we will be covering the deployment part, we will see how we implement these lr.predict part. But in most cases, as we are learning this in the beginner classes, we will only focus on using the predictions for checking the model accuracy. And then the last thing we can do is we can print the R2 score. So here we will just have lr.score. Then we score using our X and Y dataset. Then we can run that. Yeah, so 5 minutes, you can copy that and then we can summarize what we've looked at today. And maybe you can ask questions if you have any. Okay, so hope you are done, and maybe we can summarize the results that we see here. So we can see that the R2 score is at 0.46. So it means that our model explains 46% of the variance that is of the variability that is there in the data. So it's not a good model because we should have this score at something more than 0.70. So we will look at improving this score with other models. Yeah, so what I will request you to do maybe is add the line of best fit to a scatter plot. So what you should do is just pick one feature and plot it against the target. Then plot the line of best fit. Yeah, so this is something that I'll leave for you to work on. So at least do some research on that. Yeah, so that's it for the practical part. So let's have a look at what we've looked at today. So what we've looked at today and things that are new, this part here, where we are using ordinal encoder to encode our data. So what we mean by encoding is transforming categorical features to be numeric. So for example, over here, where we had the sex being equal to female, we transform that value from being equal to female to being a 0. When the value was male, we transform that value from being male to 1. And here for smokers, for example, if an individual was a smoker, we changed that from being no to 0, and maybe from being yes to a 1. Same applies to the days of the week and also time. So it might be dinner time or lunch time. So we can have zeros or ones. And that's basically how the ordinal encoding part works. Then the next thing we did is we split our data into features and the target. So for example, if we check our X, this is how our X looks like. So it has the total bill column, the sex column, the smoker column, day, time, and size column. And then if we check our Y, you can see the Y is the target column. So it's a series with just a single value column or a single variable. Then what we did next is we went ahead and imported our linear regression model. We instantiated the linear regression model, fed the model to our data, made predictions, and then got the score of our model. So this is just the basics part. So we will shift on to the advanced stuff later on, and I'll get to explain how we explain these scores and how we use the Wipred. Yeah, so that's it for today. If you have questions, you can ask. In the meantime, I'm going to upload the class recording on YouTube, and I'm also going to upload these notebook onto the shared Google Drive.